So the final kind of system that you might have is where you're trying to work out a moment where you have an oblique plane and a force acting at some angle to that plane that's not vertical or horizontal, and it's not perpendicular. So how do we work out the moments for this system? Well, once again, we know that we can break this oblique force into its vertical and its horizontal components. How can we see those? You can always use that force as the diagonal of a parallelogram. And then in that parallelogram, that helps you to see the horizontal and the vertical components. If you know this angle here, we can see that this horizontal component, which we'll call the horizontal force, is actually F cos theta. And we can see that the vertical force is equal to F sine theta. Then the complex part often comes when we're trying to work out where are the moment arms back to this point. How do we see those? Well, what we do is remember that each of the forces that we're looking at now that are making up the moment have a line of action. So we can draw the line of action for the horizontal component, and it has a perpendicular distance from that line of action back to the pivot point, and that's the distance. We'll call it DH because it is the perpendicular arm for the horizontal component. Just say we know that this angle here is alpha, well then we know that angle there is alpha, well then we know that this would be D sine alpha. Similarly, for the vertical component, we take its line of action, and from that line of action we take a perpendicular back to the pivot point, and we'll call that distance there, that moment arm, is the moment arm for the vertical, and it is D cos alpha. So that's the trick in finding those moment arms. You take the line of action and then take the distance from the line of action, which is perpendicular, back to the pivot point. So the sum of the moments for this system will be the vertical moment plus the horizontal moment. In this case, and each is force times distance. So here we have for the vertical, F sine theta times vertical times its perpendicular distance, which is D cos alpha. And for the horizontal force, we have F cos theta there times its perpendicular distance, which is D sine alpha. Sometimes you might be given those distances there, but if not, you can use trigonometry to work them out. So you can see in an oblique system you need to work out both the components of the force and the components of the distance to get the moment arms in order to work out the total moments. In this case, because they're both in the counterclockwise direction, they're both positive. And that's it.